Good morning. My name is Mbai Mbegere. I am from the Senegal National Sanitation Utility, the Senegalese government utility dealing with sanitation on urban areas. And I was for 5 years appointed as the project manager at the Swiss Federal Institute of Aquatic Science and Technology, dealing with sanitation in developing countries. And I was lecturing for 10 years at Dakar University on sanitation issues. And right now I'm coordinating at ONAS a gate-funded project on the structuration of fecal sludge market. If you want to learn a little bit more about our background, about what ONAS is dealing with, you can visit our website, onasbv.sn. We are together this morning and we want to talk about treatment technologies, principles and mechanisms of settling tank, drying bed. And when we talk about drying bed, we want to talk about unplanted drying bed and planted drying bed. But before we go further in this perspective, I just want to explain that fecal sludge management is a whole value chain that must be managed globally, from collection to transport to treatment and reuse. The goal is to make sanitation services safe and sustainable by addressing the failure to effective collection and transport, treat and reuse waste captured on on-site sanitation facilities. Right now, the technological issue is something very important in fecal sludge management, but must accompany a process of organization of the whole segment of the chain so that collection and transportation was done properly and was affordable for beneficiaries on on-site sanitation. In most of the cases, when people talk about technology, about fecal sludge management, people think about technology without thinking about all that need to be around. This is why many fecal sludge management built in Africa was not working or was always waiting right now for fecal sludge. These pictures show some fecal treatment plant implemented in Lomé, in Bamako, in Ouagadougou, in Accra. And all these fecal treatment plants are not working or are waiting for fecal sludge. And for this lecture, we will talk about fecal sludge treatment technologies. I would even say about fecal sludge pre-treatment technologies. Why fecal sludge pre-treatment technologies? Because we realized that after the treatment, the processing by drying bed, by settling tank, by implanted drying bed, we realized we need a post-treatment. We need a post-treatment. It is why I prefer talking about fecal sludge pre-treatment technologies. And for 1 hour and more, we'll talk about drying bed, about unplanted drying bed, and about settling thickening tank. What are the main mechanisms we have in these technologies? In settling tank, in drying bed, and in unplanted drying bed. We realize that many treatment systems for fecal sludge are based on system for wastewater treatment and treatment of wastewater sludge. This is a big mistake because we realize that fecal sludge and wastewater are not the same. I will talk a little bit more about that in my next slide. And because we can find major differences between these two kinds of waste due to the high variability in concentration of all constituents. We can say that fecal sludge management, fecal sludge is very different from wastewater in terms of volume, in terms of concentration, and therefore in terms of charge. Several analyses and several measurements we made in several countries allow us to understand that 1 liter of fecal sludge equals 100 liters of wastewater. It means you cannot use the same system to treat fecal sludge and wastewater. The design of a fecal sludge treatment plant need to conduct a lot of analysis due to the high variabilities that characterize fecal sludge. Both within a country and between two countries, you realize that sludge varies widely. And you cannot use, for instance, data from Ghana to design a fecal sludge treatment plant in Dakar. This is a mistake. And for instance, if in Ghana, where you have some public toilets, you realize after measurement that fecal sludge is very different in country like Senegal, where facilities are residential and consisting of septic tank. And fecal sludge management characteristics depend on several parameters. And depending on the technologies used on collection and on transportation, sludge can vary widely. If you want to implement or to design a good fecal treatment technologies, you have to keep in mind several parameters. I talk about the degree of stabilization. You have to link this to the kind of facilities you have at the household level, because according to the fact you have a latrine or a septic tank, you will realize that the degree of stabilization will be very different. The organic load is something also very, very important, because it can inform about the kind of post-treatment we have to implement later on after the settling tank, after the drying bed. Also, the water content is very important, because it can inform about the solid-liquid separation treatment we have to implement in order to improve the quality of this water. And fecal treatment mechanism are of three types. You can have a physical mechanism, you can have a chemical mechanism, you can have also a biological mechanism. And we must know that fecal treatment technologies are not as well understood as those of wastewater. The understanding is very limited, and we realize that the design of this technology is based mostly on empirical data. This is why we need to gather more evidence for the fecal treatment plant, for the design of treatment technologies. This is why, fortunately, several international institutes like IAVAX, the Swiss Federal Institute of Technology, like IHE, like IT in Thailand, and some utilities like ONAS work on this perspective in order to get more evidence for the design of fecal sludge treatment technologies. About the physical treatment, what is the objective? The objective of this physical treatment is just to allow a solid liquid separation in order to reduce the volume of water. You realize that all this will lead to a dewatering process, because dewatering is something very important in fecal sludge, because we realize that in fecal sludge you have more than 95% of water content, and in this condition you realize you cannot dump this waste with this water. This is why the first thing to do is to dewater. And this dewatering can allow to reduce the transportation cost of this waste. And when you dewater also, you realize that you disinfect. You can reduce the quantity of pathogen you can have inside this water. And it is also essential for resource recovery, because you can get, after dewatering, a solid fraction and a liquid fraction. And the solid fraction, when treated correctly, can be used as compost for fertilizers, and you can use also the liquid in agriculture or in market gardening, for instance, which is very important in developing countries. What processes are inside these physical treatment? You can use several kinds of processes: evaporation, evapotranspiration, filtration, and infiltration. And you can realize that all this will allow to reduce the volume of liquid to dewater. And all these processes play a key role in this dewatering process. About the chemical treatment? We know that coagulation and flocculation are important processes in water treatment. We use coagulation to destabilize particles through chemical reaction between coagulant and colloids. Colloids are particles inside in fecal sludge with very, very, very small density, and with flocculation, which transports these destabilized particles and makes them settle. And the objective of this chemical treatment is to improve performance of physical treatment to inactivate pathogen. However, we have to keep in mind that it can be very expensive, because you have to use some chemical like alkaline, like ammonia, and this costs a little bit and makes the treatment more expensive. The biological treatment is also another process involved in treatment technologies. And this biological process can be an aerobic treatment, can be a non-aerobic treatment, and the main objective is to stabilize. But we realize after the physical and the chemical treatment, when we put in place these kind of treatment, we realize that the quality of water treated is also very low. You have so much nitrogen, you have so much phosphorus, you have so much, I can say, pollution inside, and you have also so much pathogen. It is why it is obvious to develop a further treatment in order to reduce the organic content and in order to eliminate pathogen. This is why the stabilization is something very important. And stabilization involves the degradation of petrifiable, readily degradable material, leaving behind more stable, less degradable organics. Stabilized organic matter does not have an exact agreed upon scientific definition, but in general refer to resistance to further biodegradation. To summarize all this, we can say that treatment, several mechanisms are involved in fecal sludge treatment. We can have a physical one with settling, thickening, evaporation, evapotranspiration, infiltration. And all these mechanisms led to a dewatering, led to a reduction of the water content of fecal sludge. After that, we can have a chemical treatment with coagulation, flocculation, and the objective is just to improve the dewatering or the solid liquid separation process already involved or already in place at the physical treatment site. But don't forget that the chemical products can enhance the cost of the treatment and can make it more expensive by using some chemical product. After that, you need to improve the quality both of the liquid fraction and the solid fraction, because you have so organic and so pathogen inside, by conducting a biological treatment. And this biological treatment can be done by plant uptake in unplanted drying bed, by aerobic degradation, by anaerobic degradation, and also by aeration, thanks to the plant you have to implement in a planted drying bed. What are the main factors influencing the quality of fecal sludge? Why fecal sludge is very different from Dakar to Ghana, from Dakar to Accra, from Accra to Bamako, and from Bamako to Thailand, for instance? It is very different because the technology and the emptying mode are very different. If, for instance, in the country you deal with manual emptying or with mechanical emptying, you realize that the quantity of solid inside the fecal sludge will be very different. Because in a manual emptying, you realize that emptiers can mobilize all the fecal sludge, or in mechanical emptying, you realize that sometimes only the liquid part is pumped. In Dakar, for instance, we have 150 trucks working every day to empty the fecal sludge content of the pit. But we realize that 60% of these trucks are pumping truck. And when you have a pumping truck, we realize that this truck can pump only the liquid, because the pump is not enough strong in order to mobilize the secant sludge. It means at the fecal sludge treatment plant, you have a very liquid fecal sludge, because all the solid content remain inside the pit. It is why, according to the kind of technology you have in your country, it can impact on the quality of fecal sludge you have. The storage duration is also something very important, because according in a city like Ouagadougou, for instance, you have more latrines than septic tank, and you have to empty this latrine so often, and in this condition you realize that the concentration of the level of stabilization will be very different than in Dakar, where with septic tank you can store the sludge for 2 to 4 years, and in this condition you can have a very stabilized fecal sludge. The quality will be different. For instance, I just give an example. In Dakar, we planned it with the Gate Foundation to implement a biogas treatment system, and we realized, thanks to the quantity of organic matter we have in the sludge, that a biogas system will want to be profitable in Dakar. And in Ouagadougou, because they are latrines, we have so much organic content ready to be stabilized, ready to be to go to a further degradation in order to get more methane, for instance. This is why the storage and the kind of facilities will be very, very important. The composition of fecal sludge is also very, very determinant. For instance, if you have grease, waste content, all this will make fecal sludge different from a country to another one. The groundwater is also very important. In Dakar, in some part where the water table is very high, we realize we have every day infiltration of groundwater into the pit. And what is the consequences is we realize that this sludge is very diluted, and when you make analysis you have something like a wastewater. This is why you can have several situations with several different kind of fecal sludge. Fecal sludge may also contain several things like sand. You can have also solid waste like clothes, broken bottles, batteries, bags, plastic bottles, metal syringes. You can have also pharmaceuticals, chemical pollutants from craft industry, oil, dyeing effluent, and so on and so forth. This waste looks like garbage. It is why you need, if you want a good fecal sludge treatment system, to make a good screening before the treatment. A screening is very important, and you have also to put in place a good organization to transport this solid waste to a landfill. It is something important. If you say, my concern is just to treat fecal sludge, you realize you have some garbage beside, and you need to take it over. Dakar experience show that a succession of 2 grids before the settling thickening tank or before the drying bed is something very important. If you put 2 grids with a respective bar distance of 20 millimeter and 25 millimeter, you can eliminate a big part of solid waste. But you need to clean every couple of hours this grid in order to remove all the solid content we arrive to eliminate with such a grid, and to put this waste to a landfill. This is why the success of a good fecal treatment plant can only be achieved through a good system of screening. It is something very important. Now, what kind of treatment technologies after the screening process we have to implement in order to improve the quality of fecal sludge? Several treatment systems are used in fecal sludge management, and this system can be co-composting with organic solid waste. We can have some planted drying bed. We'll talk a little bit more about that. We can also implement an unplanted drying bed. A settling thickening tank is also a used technology we use all over the world. A settling pond, an anaerobic digestion, a core treatment of fecal sludge with sewage sludge, a core treatment with wastewater. But we have to keep in mind that all these systems generate both a solid fraction and a liquid fraction. And this solid and liquid fraction need to be further treated in order to improve their quality. It is something important. It is why in the beginning I don't talk about fecal sludge treatment technologies, but I talk about fecal sludge pre-treatment technologies. because after that, after the drying bed, after the planted drying bed, after the unplanted drying bed, after the settling thickening tank, you need always to implement a post-treatment. And when these solid fraction and liquid fraction are treated correctly, are post-treated correctly, you realize you can use the solid fraction in agriculture. You also use the water for irrigation, for instance. Or the solid fraction can be also used as fuel, as we plan to do with the omniprocessor in Dakar, as we, Iavak Sandek, work with the Senegal National Sanitation Utility in order to use this fraction as fuel for cement factory. This is why this post-treatment is very important, because it allows to create some added value from the fecal sludge treatment technology. Now we talk a little bit about settling thickening tank, the first technology we have to deal with in this course. And this picture is an illustration of fecal sludge treatment plant in Rufisque near Dakar, the capital city of Senegal, and in Ghana, in Accra, in Ghana. And all these systems are working right now properly. What about the settling thickening tank? We realize that this fecal settling thickening tank works like a big open septic tank. If you know a septic tank, it works like a big open septic tank with a short residential time and with a solid liquid separation, which allow the formation of several layers. We have in the bottom a solid layer, you have also a water layer, and you have a third layer with grease, so call it scum. And the settling process that began immediately after the feeding of this bed is followed by a longer thickening process, resulting to a more compact fecal sludge. But we need to be attention, because a long thickening time undermine an effective pumping of thickening sludge to the other bed, to the drying bed, for instance. It is why you need to be very quiet about this aspect. In Dakar, for instance, we realized that after 1 week feeding of this bed, we can have 1-2 week thickening in order to get a more compact fecal sludge. We have to try further in drying bed. We conduct several sedimentation tests in Dakar and in Accra, and we realize that the volume of settled sludge can be roughly around 30-35 of the initial volume. But we realize also, thanks to this test, that the public toilet sludge does not settle easily because we have too much bound water. To have a good settling thickening tank working properly, you have to avoid the maximum possible the turbulent, no turbulent flow. It is why we implement some buffers in the entry of the settling thickening tank. The ratio between width and the length can be 1:5:10. And as I explained earlier, not fresh sludge alone. You need to mix this fresh sludge to a more stabilized sludge in order to make it settle easily. Normally, we have two settling thickening tank units alternately operated. The performance of this settling tank depends on the operation mode. As I explained in the last slide, 1 week of loading is sufficient, and after that, you can have 2 weeks of thickening in the settling thickening tank in order to make more compact this sludge. And you have some issues when processing fresh sludge because of the poor sedimentation. And we realize that in several African cities, you have so many public toilet, and in these public toilets you can get some fresh sludge. It is why we have to think a little bit more about the treatment of this sludge. Here you have a dislodging of fecal tank in Accra, in Ghana. And as I explained also, we have to know that always we need after treatment, because liquid and solid are still high in pathogen. Sludge not yet stabilized or fully dewatered. But we can also see that fecal septic tank is especially beneficial when treating fecal sludge with low solid in temperate or rainy climate. And when you use a settling thickening tank, you can reduce the area of following treatment steps. You can reduce the footprint of your fecal sludge treatment with such a technology. In the post-treatment aspect, we can use a stabilization pond. And the stabilization pond is something very important because it allows very low maintenance, because we have some cones with this technology, because we need so much area for the implementation of this technology. The footprint is so high with the stabilization pond. And this space is a big issue in cities in developing countries. And also a major problem is it is difficult to treat fresh sludge with stabilization pond due to the high concentration of ammonia we have inside. We need to operate a good settling thickening tank. We need sufficient volume for sludge accumulation. We need also a sufficient depth, more than 1.5 meter. A loading resting cycle much shorter than in sedimentation pond, where we have several months for this resting cycle. We need buffer in order to make the basin more turbulent and to allow a good settling and a good thickening of the sludge, and to allow also a good retention of floating scum. And we need for the design to plan an accumulating sludge of 5 to 9 liters per kilo of total solid. And we need also to take care about the scum, because this basin is from Canberra and fecal treatment plant in Dakar. And you realize that if you don't take care correctly with this scum, you can have some plant growing on it, and it doesn't work properly in this condition. The sludge volume index is a very important parameter. It is an empirical method to determine settleability of sludge. And for this, you use some Imhoff cone like what we have in this photo. And you have to just calculate the volume of fecal sludge settle in this cone during 1 hour. And with this sludge volume index, you can calculate the quantity of total solid you can have in your basin, and it can help you to design correctly this technology. What about the removal rate? We try in this slide to compare what happened in a sedimentation pond and in a settling tank. And we realize that according the physical pollution and according the organic matter, you realize that the settling tank is working correctly. We can have more than 90% of retention of the suspended solid. And you realize that the organic matter is also correctly retained due to the fact that this organic matter is mainly solids, and in this condition you can eliminate between 70 to 95% of this organic matter. And we compare also several treatment technologies from Dakar to Accra, and we realize that this technology is very efficient. When you have a long thickening time, you can improve the quality of this water, but you realize that you will face several difficulties to remove this sludge from the tank. You have to balance between this thickening time and our objective to pump this sludge into the drying bed. With this formula, it is important with this formula, you can calculate the quantity, the concentration of total solid you can eliminate through your fecal sludge settling tank. You can use it to also, if you have an objective of elimination, to calculate the volume of the basin you have to implement and as a thickening tank. In this slide, we have the example of the Camberen fecal treatment plant, which is the first fecal treatment plant implemented in Dakar. And we realize in this plant, as I explained, we have two thickening tanks that operate alternately. And after 1 week thickening and one week feeding and 1 week thickening, you realize that more than 90%, 97% of the liquid is as supernatant is sent into a wastewater treatment plant, an activated sludge close to this fecal treatment plant. And also we can send 60% of solid to the drying bed. Just you can realize how efficient is the solid liquid separation from this Camberen treatment plant. And as I explained, it is important before the treatment to implement a screening process in order to reduce the big quantity of solids, of garbage you have also in your fecal sludge. You need also an area where you can store the dry sludge coming from your drying bed. But a long storage period can improve the quality of this sludge and can allow all the kind of reuse of these dry solids. After the thickening tank, we will talk about drying bed. We have two kinds of drying bed: a non-planted drying bed and a planted drying bed. About a non-planted drying bed, it consists to a shallow filter filled with sand and gravel. And it contains an under drain for the liquid, and free water will evaporate from the surface. It means that in this technology we can dewater thanks to the evaporation and thanks to the infiltration and drainage. The facility, the sludge drying bed, unplanted drying bed facility, will contain a number of beds. In Dakar, for instance, at the Camberen fecal sludge treatment plant, we have 10 beds. Sludge is loaded into the beds periodically, for example, once every couple of weeks. Water is let to evaporate and drain. We realize that the dewatering is mainly the fact of the infiltration and drainage and the evaporation. 650 to 7% or to 8% of the water losses is due to this infiltration and drainage. But after a time of drying time, we need to remove this sludge from the bed in order to develop any other kind of reuse. In this figure, you have an illustration of beds from Camberen, from the Camberen fecal sludge treatment plant. And in these two beds are fed with thickened sludge from the thickening tank, which operate alternately. In general, to design a drying bed, it is relatively simple. And to construct and operate, it is also so simple. You have to keep in mind some crucial elements. The sludge loading rate in kilogram of total solid per square meter per year. You have also to be very quite careful about the inlet point, because the objective is to have a good distribution of the thickened sludge into the bed. And we have also to think about the space available, because about this availability can inform about the number of beds we have to put in place in your drying bed. And also in the calculation, you have to make a survey in the country in order to know the number of trucks you plan to welcome in your fecal sludge drying bed. And some numbers, you have 100 to 200 kilogram of total solid per square meter per year, 25 to 30 centimeter sludge accumulation with 15-day retention time, and sludge need to further post-treat it, because after the drying time of 15 days, you cannot inactivate it, all the pathogen. When you make some measurement, you realize that the number of helminth eggs is relatively high, and you need to post-treat it in order to reuse this dry solid as a compost, for instance. And if you dry correctly after 3 months these solids, you have something like compost. About the sizing, you have to just keep in mind that you need 0.05 square meter per capita. And as I explained earlier, the drying time, the dehydration time will be around 7 to 14 days. And the quality of the sand is something also very, very important, because the main issue of a drying bed is clogging. You need to keep in mind that when the bed is clogged, you realize that the water losses will be mainly by evaporation than drainage, and it will take time to correctly dry your sludge. And as in a settling tank, fresh sludge cannot be dried correctly in a drying bed. It is why you need, as I explained in the settling tank technology, to mix this sludge with more stabilized fecal sludge in order to get it dried correctly. About the performance, we realize that you have good efficiency with the drying bed. According to the physical pollution, the suspended solids, for instance, you can eliminate more than 95%. The organic matter, the organic content is also, through the COD, is eliminated from 70 to 90%. And you can eliminate the helminth eggs from 100%. But to eliminate the helminth 100% the helminth eggs, you cannot dry just for 15 days. You need to store these biosolid to dry it more than 3 months in order to deactivate all the pathogen you have inside. The characteristic of the substrate is of paramount importance for the functioning of this filter. You need to get a regular size for sand, and sand need to be washed rigorously before being installed in the bed in order to avoid to a maximum the clogging process. And you can have two kind of gravel, because you have 2 layers of gravel. The first layer is small of the top, 5 to 15 millimeter of diameter, to prevent sand from washing away, and larger at the bottom. You can have a larger layer of gravel with the diameter around 20 to 40 millimeter to avoiding clogging. But in Dakar, what we realize, it is important sometimes to install an anti-contamination layer between the sand and the first gravel layer in order to avoid clogging, in order to improve the infiltration. We realize that when we deal with that, we are improve a lot the efficiency, and we realize that this bed are clogged not so frequently. And right now, we are to conduct several tests in Dakar and in several other countries in order to see the best filtration material. We are about to process or to implement, to run a new fecal treatment plant in Dakar, in Kermassar, for instance. And what we do, we replace some beds, the sand with interlocking pavers. And the objective was just to see how we can improve the quality of the biosolid. With these interlock powers, we realize that the infiltration is better, and we realize also when we remove the sludge, we don't remove sand with it, because in a normal drying bed, you have to replace every 3 months some part of the sand, because when you remove the dry solids, we remove also sand, and with these interlock powers, we can avoid doing that. The diameter of sand is also very important. If you have larger grain and larger pot, it means you can have more accumulation of organic matter between or within this material, and it causes some clogging issues. And what is better is to have some sand with diameter of the particle from 0.1 to 0.5 than 1 to 1.5 millimeter. Other condition also, sand particles do not crumble. Sand need to be easily available. You cannot implement a fecal sludge treatment plant in Bamako and come to Dakar just for sand. You need to have sand locally. It can reduce the cost of the fecal treatment plant. It is something very important, this availability of the sand at the local level. And we have also to replace sand regularly, because as I explained earlier, when you remove the solid, you can remove some sand with this dry solid. And after 3 months, you realize that you can lose some sand, and we realize that every 5 or 10 drying seconds, you can lose few centimeters of sand. At Camberen fecal treatment plant, we lost 5 centimeters after 25 seconds. You have also to, as I explained, to remove regularly these solids, and when you remove it, you have to store it somewhere. And this storage is something very important, because after 15 days, I explained it that you cannot deactivate correctly the pathogen. It is why you have to store it somewhere inside the fecal treatment plant in order to improve the stabilization, in order to make the deactivation of the pathogen, in order to make these dry solid reusable like compost or like fuel. If you plan to use it like fuel, for instance, you don't need to store it for 3 months. You just need to remove it properly in order to reuse it in a factory or in another location. In Camberen, if I take example from Camberen, I talk a little bit about Camberen, because it is one place of the world where we find a drying bed working correctly. Leachate, we realize after the drying process, the leachate we collect with the drainage system is highly concentrated on total solid, on suspended solid, and on organic matter. If you realize that with the leachate you can have more than 3,600 milligram of COD per liter, it means it is more concentrated than a normal wastewater coming from household to a wastewater treatment plant. It means you need to deal with this pollution. You cannot dump this pollution directly in the environment, because it can cause many environmental issues. It is why you need to develop a post-treatment. I talk a lot about this necessity to implement a post-treatment, because the liquid and the dry solid coming from these technologies are always concentrated on pollution. And you can remove the dry sludge manually. And one worker is used in Camberen 2 days for removing 70 centimeters of dry sludge, 7 centimeters of dry sludge from a 130 square meter of bed. And this dry sludge density is about 300 kilograms per square meter. And the fecal treatment plant of Camberen produce about 600 cubic meter per year of dry sludge. It means if we reuse correctly this sludge, we can create, make this, we can have some great added value. We can make this plant at least profitable, or at least balance it correctly in the operation cost. Sludge is stored behind drying bed, later collected by public work company for soil enrichment. This illustration show the removal of fecal sludge in a fecal sludge treatment plant, and you realize that we remove it manually. But what we want to notice from that, we need to protect the day laborers dealing with that by putting gloves or something else. After this unplanted drying bed, we'll talk about planted sludge drying beds, which is a little bit the same, but in this technology we have some plants which grow in the bed in order to improve the quality and of the treatment. Planted drying bed is kind of bed with porous media that are planted with emergent macrophyte. In this photo, we have a bed with Echinochlora pyramidalis operating in Dhaka. And when you look at this photo, you realize how nice was the growing of this plant. This plant is well adapted to fecal sludge drying bed. And we also realize that plant used in fecal sludge treatment plant for planted drying bed come from wetlands or marshes or swamps. And these plants are some characteristic because they have to deal with some specific condition. They have to get the ability to grow when fully or partially submerged in water. Because you have some drought, some wet condition, and in this condition, this plant has to face with that. And we have several kinds of plant we can use for planted drying bed. And the organization of planted sludge drying bed is a little bit the same than the planted drying bed. But now we have plant on the top. And plant need to withstand with varying watering regime and nitrogen loads. And we can have in temperate climate some good evaporation up to 2.5 centimeters of water, and on very hot days. And you realize that in some tropical climate, the water losses can be very high. If you take the example of a plant like a typhoid, you can lose around 40 liters per square meter per day. You realize that thanks to the evaporation, we can dry it very, very quickly. We can speed up the process of drying in this bed. And we realize that 95% of volume reduction over a year at a total surge loading depth up to 490 centimeters and 69% of dry matter. And as I explained, you realize that it is a normal bed with the different layer of gravel, the layer of sand, and you put plant inside. You have a pipe for the drainage water, and this water is not... the concentration of the pollution in this water is very important, and you need to develop an after treatment with a stabilization pond or with an activated sludge, for instance. And what are the main requirements for the plant? The plant needs to grow very fast under diverse conditions. And high transpiration capacity is very important because don't forget our objective is just to dewater. To dewater by evaporation, by evapotranspiration, and by infiltration and drainage. It is why if you have some plant with high transpiration capacity, the dewatering time will be less important. And this plant need to be tolerant to different water level and drought condition. And we realize also that the sensitivity to extreme pH and salinity is very important, because fecal sludge, the salinity is very high, and you don't have, you cannot accept any kind of plant on that. And a deep growing of rhizome and root system, because you will realize that the root system can fight against clogging. When the roots is developing correctly in the bed, you realize that clogging will not happen so often, and in this condition you can operate your bed for several times. Ability to build new roots on the node when they become encased in sludge, and these plants are to be readily available, indigenous and non-invasive. You cannot go in another country to introduce this plant. You have to get this plant locally. Before performing a fecal sludge planted drying bed, the first thing to do is to think about the availability of the plant. If the plant is not available, you can think about other technologies. Type of plant, 4 plants are well used in a planted drying bed. You have the reeds, you have cattail, you have papyrus, you have also antelope grass, and all these plants are seasonal to permanent, can resist to inundation, to flooding, can also live when we face drought condition. This is why this plant can be very, very, very important. If you take the case of Phragmites, it can live in flooding with water level up to 60 centimeters compared to the soil level. And in this plant, in this photo, you have these species, Echinochlora phragmites, the typhus, the papyrus, growing in normal drying bed. And you realize that they grow correctly, and these plants are well adapted. And we can find these plants all over the world in tropical climate, and sometimes they can be reused after they are cut it away. What is the main role of the plant? We have 3 roles of this plant. This plant can have a biological role with the nitrogen uptake. We can realize that fecal soil and wastewater are very rich on nitrogen and phosphorus. And this nitrogen and these phosphorus are the main nutrients the plant are needed for the growing. It is why by introducing this plant in the bed, we can enhance and improve the elimination of this kind of pollution. This is why in this perspective, we realize that the planted drying bed is more efficient than planted drying bed according to this pollution. We have also something very important, is the contribution of the plant on the drainage and the infiltration. The root and stems system help to maintain permeability. You have some preferential way creating by the roots, and in this way the water can infiltrate and drain correctly. We have also some kind of oxygen transfer thanks to the plant through the roots, and with this oxygen we can allow the development of the microorganism. And this microorganism is also very effective on the elimination of the organics. In this condition, we can also improve the elimination of this secondary pollution in the fecal sludge. And this illustration is some plant we have on some drying beds. About the performance, we realize that the level of elimination is very high. If you look about the nitrogen, about total nitrogen, you realize that we can eliminate 90 to 96%. It means that it is more efficient than the unplanted drying bed. About element eggs also, we have some percentage of elimination very, very high. 100% of element eggs can be eliminated with such a technology. And according to the solids, we have the same elimination than an unplanted drying bed. It means that this bed is better, but is the efficiency is better, but we need to be more organized for the operation of this bed, because you have plant, and every time you need to cut this plant, you need to replace this plant, you have some mortality and some depth, and in this condition this plant is a little bit more difficult to operate than an unplanted drying bed. And about the dryness, we can have more than 30% of water. About the operation parameters, I just want to talk about something very important. It is the acclimatization phase. Most of the drying bed we already run in several countries fail because of this acclimatization phase, because people doesn't know how to make this plant growing correctly in this new condition. And it is why it is important. The Swiss Federal Institute of Aquatic Science and Technology conducts several studies in Dakar in order to know how to acclimatize these plants. And we realize that the startup, you have to start this plant with this bed with plant density of 4 to 12 shoots per square meter. In the beginning, you have to apply domestic wastewater or tap water and gradually add fecal sludge until the plant achieves a height of 1 meter. After that, later on, you can begin feeding your beds with fecal sludge. Plant up to 3 times. About the plant harvesting, you have to harvest it 3 times a year following a few years of operation or during the sludging. And depending on plant type, the growth station and the growth status and valorization option valid especially for Echinocula pyramidalis. And it means this plant, this bed is very important, is very useful when you have inside some plant you can reuse locally. And this plant will contribute to create some added value from this fecal sludge treatment technology. About bed operation, you need, as in a certain thickening tank, to pre-treat fecal sludge before feeding the bed. And what kind of pre-treatment is to implement a screening process, some grid before the settling tank, and the settling tank play also a role as a pre-treatment for this bed. Weekly or bi-weekly, we need to feed the bed in a sequential manner by batch. You have also to ensure a regular distribution of the sludge across the whole surface. This is something very, very important. It is why the inlet point is something very important, because you need to have a good repartition of sludge in the bed in order to avoid to have some drought area and some wet area. And in this bed you can see some plant dying because they don't have some wet condition in the bed. What about desludging? The first desludging depends on the projected height of the last bed to be emptied. You have to observe an additional period of rest before cleaning. And this additional period is just to allow an elimination of pathogen. In an unplanted drying bed, we talk about storage of dry solid outside the bed after the 15 days of dryness. But here, you can use the bed to better dry, dewater the dry solid, also to better disinfect the sludge. You have also to leave a few sludge on bed, less than 5 centimeters, to allow a good plant regrowth after the first phase. Here you see, here you have in this photo Echinocula pyramidalis, which is well used for other fodder plant. It means that, as I explained earlier, if you implement in your bed such kind of plant, you can create so much added value, and you can get some cash from the treatment, and this can help to balance the cost of the operation of the fecal sludge drying bed. Thank you for your attention.